Welcome to another episode of Chalk Talk with Teacher Mitch. Today's lesson will be all about the difference of two squares, or DOTS. Before we start with our discussion about difference of two squares, let's ask the following question. What answer do you get when you multiply binomials in the form of sum and difference of two terms? Let's try to answer this question by answering the following examples. So when we have two binomials in the form of sum and difference of two terms, all we have to do is to multiply the first terms and then we multiply the second terms. If we multiply the first terms, we get x squared, and if we multiply the second terms, we get negative 16. Let's go to the next example. 2x minus 5 times 2x plus 5. 2x times 2x is equal to 4x squared. And negative 5 times positive 5 is equal to negative 25. And the third example, negative 3x plus 4 times 3x plus 4. So if we multiply the first terms, it will be equal to negative 9x squared. And the second terms will be equal to positive 16. Let us look at the answers. X squared minus 16, 4x squared minus 25, and negative 9x squared plus 16. And let's ask the question, what do we get when we multiply the sum and difference of two terms? What can you observe with the three answers here? Okay, first observation we have is that the first term is a perfect square. And then the next observation is that the second term is also a perfect square. And then the third observation is the middle operator for the first and the second example is subtraction. And for the third example, one of the terms is negative. When we multiply the sum and difference of two terms, we get an answer in which the first term is a perfect square, the second term is also a perfect square, and the middle operator is subtraction, or one of the terms is negative. In other words, when we multiply the sum and difference of two terms, we get the difference of two squares. How do we identify if the polynomial is a difference of two squares? There are two considerations. The first one is the two terms should be perfect squares. And the second consideration, one of the terms must be a negative, or the middle operator should be subtraction. So we have to take note of this before we factor in the form of difference of two squares. So how do we factor difference of two squares? First is we get the positive square root of the first term. Second, get the positive square root of the second term. And then factors must be in the form a plus b times a minus b, where a is the root of the first term and b is the square root of the second term. Before we proceed to the examples, let's define first what is a perfect square. A perfect square is a product of a number being multiplied to itself. Examples of perfect squares are the following. If we multiply 1 times 1, the answer is 1. The product is what we call the perfect square. Another example, if we multiply 2 times 2, the answer is 4. 4 is a perfect square. If we multiply 6 times 6, the answer is 36. And 36 is a perfect square. So when you multiply a number by itself, it will give you a product which we call a perfect square. For coefficients, it is easier to identify if a number is a perfect square or not. But how about for variables? How do we identify if a variable is a perfect square or not? There is only one condition for variables. Okay, a variable is a perfect square if and only if the exponent is an even number. So example of a variable that is a perfect square is x squared, or a to the power of 100, or a to the power of 50, or x to the power of 82, or z to the power of 10, and so on. Identify if the given is a difference of two squares. If it is, we factor. Let's identify first for number 1, x squared minus 36. Remember the considerations. The two terms should be perfect squares, and one of the terms should be a negative. So let's identify the first term first. Is x squared a perfect square? Yes, it is, because the exponent of the variable is even, so it is a perfect square. How about 36? Is it a perfect square? Yes, it is, because the root of 36 is 6. When you multiply 6 by 6, it is equal to 36. Now let's go to the second consideration. Is one of the terms here a negative? Yes, it is. So negative 36 is a negative number. So this one can be factored using the DOTS method. So remember, when you factor, it should be in the form a plus b times a minus b. So let's have that form. 1 is a plus and 1 is a minus. What's the root of the first term? The root of the first term is x. How about the root of the second term? The root of the second term is 6. And this is our final answer. The factors of x squared minus 36 are x plus 6 times x minus 6. Let's go to the second example. Let's identify if this can be solved using the method on the difference of two squares. Is the first term a perfect square? Yes. Second term a perfect square? Yes. Is one of the terms negative? Yes. So this can be solved using DOTS, or difference of two squares. So it will be in this form, plus here and a minus here. So what is the square root of 9a squared? The square root of 9a squared is 3a. So we write 3a in the first term. How about the square root of 1? The square root of 1 is 1. And this is our final answer. Now let's move on to the third example. f to the 6th power plus 400. Is the first term a perfect square? Yes, it is. The second term a perfect square? Yes, it is also. Is one of the terms here a negative? No, you cannot find any negative term here. So this one cannot be factored using the DOTS method. So we don't have a factors for this one. Let's move on to the fourth example. Is the first term a perfect square? Yes. Second term a perfect square? Yes. Is one of the terms negative? Yes. So this can be solved using the method on difference of two squares. So it should be plus here and a negative here. 16b squared, the square root of 16b squared is 4b. So we will write 4b in our first term. And the square root of 81 is 9, so we will write 9 here. And the factors of our difference of two squares are 4b plus 9 and 4b minus 9. Thank you for watching, and please don't forget to like and subscribe to my channel. Click the bell icon so that you will be notified with all the tutorials that I will be posting on YouTube. Thank you and goodbye.